Good morning, everybody at Chesapeake Forum. Thank you so much for joining us for this program. Peggy Rennels is somebody that I snagged on a trip to Poplar Island, but she had been involved with some of our other courses, and we got to talking, and I asked her if she would mind filling us in from an expert's perspective on all this stuff we're hearing about vaccines. So, Peggy, I'm turning it over to you.
Yes, this is challenging for a couple of reasons. One, vaccines is a massive and complicated topic. And to try to synthesize it, I thought about bringing this book I have, which is about this big and this thick called Vaccines. So trying to condense that into a talk is challenging. Also challenging, though, is I know in the audience there are individuals who have taught biology to high school students, who have worked for the FDA, who are retired physicians like me, and probably others whose last biology course was in high school. So trying to cover that is challenging, but we'll try. First of all, who am I? I was born and raised 5 miles down the road here. My brother and my father are both physicians, so I couldn't let my brother outdo me. I had to become a physician too. And I met and married a young faculty member at the University of Maryland School of Medicine. So I stayed on the faculty there and became a professor. And my area of research was clinical vaccine development. And I was fortunate that there was a vaccine development center at the University of Maryland, which permitted me to do that. So let me go ahead with that background and launch into my talk. Some of this will be stuff some of you already know, some of it will be new to you. Medicine and science and vaccinology have their own vocabulary. And I'm going to go over some of the terminology that you need to be familiar with. If at any point I've lost you, make me stop. Make me explain it again. It doesn't mean you're stupid. It means I'm not explaining things well. So let's start with something very basic, the bloodstream, because you have to know what white blood cells are and what they do to understand immunity. So what are the components of blood? We have the red blood cells, we have that carry oxygen, platelets needed for clotting, and then the white blood cells, which do a lot of things to protect us from toxins, from infecting agents that clear up our bloodstream. And antigens and antibodies. Antigens that's any foreign substance that may enter your body, that your body reacts to by forming antibodies. So antigens are on bacteria, they're on viruses, they are toxins. All of these are considered antigens. So anything an antibody reacts to protect you is called an antigen. Antibodies then are proteins that are produced by your white blood cells to attach to antigens and block them from making you sick. Is that so? And it's like a fist and a glove. Okay, here's your antigen, here's your antibody that attaches to it. Is that kind of clear? Okay. And white blood cells are critical for protecting us. And the different types of white blood cells that protect us are macrophages, and these are like amoeboid cells that travel around in your bloodstream and body and ingest and destroy foreign material. And another white blood cell is B lymphocytes. And these are the white blood cells that produce antibodies that inactivate the bacteria, viruses, toxins. Then there are T lymphocytes, and they destroy infected cells. Okay? Is that pretty clear? And here's just a pictorial representation. Okay, B lymphocytes producing antibodies, T lymphocytes that that destroy infected cells. But this was just so pretty. Here is a cell. This is the nucleus of the cell where your DNA is. And your DNA then makes a template for RNA, which is made here in the endoplasmic reticulum. That's one of those terms you don't have to remember. Whoa.
It's fine, it's just an automated message.
Okay. Okay, the messenger RNA then moves to the Golgi complex, which is where the antibodies are made and are encapsulated and go then to the surface and get extruded from the cell.
I have a question.
Sure.
Does every cell have the capability of producing different types of antibodies? Every B cell does. Not every cell in your body. Every B lymphocyte cell does. Any other questions? Okay, and I thought, I loved this. This is a diagram to show an antigen on a cell and an antibody attaching to it. And I think it gives you an idea of how complicated these proteins are. And the characteristic of a protein is its shape. You know, it is made of different components, and it forms very different complicated shapes. So that's why it can attach to an antigen. It's really, it's like a puzzle. Now, what's a vaccine? A vaccine is a preparation that stimulates the body's immune defenses against disease. We just talked about the body's immune defenses, the white cells, the antibodies. And there are lots of different types of vaccines that we use. It can be an entire virus or bacterium that's been inactivated, detoxified, so the whole organism killed, inactivated, or weakened. And examples of this are the measles, mumps, rubella vaccines and rotavirus. Those are whole virus vaccines that have been weakened or inactivated. Then there are subunit vaccines, acellular pertussis. In the bad old days, we were given whole cell pertussis that had been inactivated, and it caused whopping reactions. You know, your arm or your thigh swelled up, you got raging temperatures. Well, they've gotten around that by just taking part of the bacteria and including part of the bacterium in the vaccine. Another subunit vaccine is influenza. They just take, the influenza has these projections on the surface, hemagglutinin and neuraminidase, again, you know that, but they take those that are the ones that are coming through to cause disease that season, and that's what the vaccine consists of. It's not the whole organism. Antitoxin, those are some of the oldest vaccines, the first vaccines ever developed. It's basically the toxin that has been detoxified by eating. And that's the diphtheria and the tetanus vaccine. And now we have mRNA vaccines, which are a brand new world, which I'll get to later. It's a totally different ballgame. Routes of immunization. The first vaccine was smallpox, used in the 1700s by Jenner. And the way it is administered is you get this little lancet, and they just take a drop, boom, 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 put it in your arm. Mine was in my thigh. My dad gave it here because he knew bathing suits would never get there. Intramuscular, this is how a lot of them are given. Some are given orally, like rotavirus vaccine, because it is an infection of the intestine. And so you want to stimulate antibodies at the surface of the intestine. Intranasal flu vaccine, given intranasally. Again, you want to stimulate mucosal immunity or antibodies at the mucosa to prevent it from getting into the body. Is that all? Here's Jenner giving the smallpox vaccine. Here's a timeline of routinely administered vaccines when they were first introduced, and then and when they were recommended for use by the FDA and by the CDC Advisory Committee on Immunizations. And you can see there was there were their early vaccines, and then there was sort of a heyday of new vaccines being introduced. And this is when I came into the field. And so it was great because this is where I built my career on. This is how I became a tenured full professor, is by doing the studies and reporting them to the CDC, the FDA, and helping to get licensure for them, and then going around and educating pediatricians around the country about them, how they worked and how to use them, et cetera. Vaccine impact. The only thing that it has perhaps improved human health more than vaccines is safe drinking water, toilets, and safe water. I mean, this is absolutely remarkable. And if people would understand this, if we could get rid of the trash and social media, why would you not get vaccines? Why would you not vaccinate your children? And it would be one thing if it was just a decision that affected you, but it isn't, because these are contagious diseases. So unless you're living in the wilderness and never interact with another human being, it isn't just a decision you're making for yourself.
Are those numbers that have zeros after them for morbidity, the 175, it was more than 175,000 for diphtheria, wasn't it?
Oh, annually.
Oh, annual, okay.
Annually.
Amy, it might be interesting how many in this room had measles.
Measles.
How many had lumps?
How many had chicken pox?
How many had chicken pox?
Yep.
And now,
You can't go to school now, you can't register at the public school unless you have
yes,
a
you've
lot of
got
those
That's right.
vaccines in place.
That's right. Okay, and this is COVID. The weekly death rate by COVID vaccination status. What? Why would you not get vaccinated? And here are the vaccine preventable diseases that well, influenza, it's only about 80% effective. So we still do get influenza. But we've almost eliminated these. Okay. Yeah,
Question. HPV.
Yeah.
How, I guess my question is, how long was that vaccine in clinical trials before the FDA gave their stamp of approval?
oh, long time.
And then they still discovered a lot of adverse events, at least in the general press. There were some reports of some adverse events relative to the vaccine. Can you talk to that?
HPV.
Yeah, not HPV, to my knowledge. And gosh, I went to all the meetings and for a brief period worked at LexisNexClimb, and they were bringing that to licensure. And there was a lot of concern because if it was really going to be effective, you got to give it before kids are sexually active. And people didn't want to believe their precious 12-year-old, might be sexually active. And so there was a lot of controversy earlier about that. Number of injections in the first 18 months. Well, when these vaccines were coming from licensure, they were just studied as individual vaccines. And it got to the point where it was ridiculous. Kids are getting 6, they get here. It's like, whoa. So a lot of what I did were studies of combining the vaccines because the combination vaccine, not only people understand, but it has to go through all the same testing, approval, licensure as a single vaccine. And so that generated an enormous amount of work for people like me and, paid my nurses' salaries. And it was good for me.
Is that because in combining them, sometimes there could be reactions that?
Well, there may be interference in the immune response. Or yes, you might get an increased reactogenicity.
So how far did you cut back on those number of pokes?
Way back, let's.
You just wanted the children to like you.
Yeah. Oh, there are combinations of 6 different vaccines, in one shot now. I can't, and every manufacturer has different combinations, so
Oh,
it's
that
not
must be
an
fun.
easy, yeah, it's not an easy answer. Okay. I was sort of on the ground floor of rotavirus vaccine testing. In fact, I was the first investigator to give rotavirus vaccine to an illness in the US. So I'll just talk you through my experience of all of the different stages of bringing a vaccine to licensure. Okay, well, I was assigned this.
my boss, the Center for Vaccine Development, had an NIH contract and to test vaccines that they developed in their laboratories. And one of the vaccines that the NIH lab developed was rotavirus vaccine. So they turned to my boss, who turned to me and said, Peggy, you're going to test it. Okay, I've never done a vaccine trial in my life, but I had to learn how to write a protocol, how to get the Human Volunteers Committee to approve it, then go out to pediatricians' offices who knew me and trusted me,
And find volunteers.
and get them to approach the families with young infants and keep a list of parents who potentially would be interested, and then send a nurse out to talk with them. And those who agreed, of course, then we would collect the safety and the immunogenicity, designed a reaction card, called them every day. And interestingly, one of the things we asked was fussiness. Is your child more fussy? And the day 1, 2, 3, et cetera. And the interesting thing is that 40% of the vaccine recipients, the parents said the kids were more fussy. 40% of the placebo recipients, the parents said their kids were more fussy. And that just shows you why you need a placebo control.
How large a trial is that typically at this stage?
Oh, I enrolled, well, I'll go through the phases of trial. You have phases 1, 2, and 3. The first phase is maybe 100 or so. So that's just to pick up really frequent adverse reactions. And then you go to a phase 2, which may be a couple thousand. And then you go to a phase 3. And I'll talk about the rotavirus experience. So, okay, so how am I going to do this trial? Well, we got to collect stool. We're going to look at efficacy. So here's my garage with ice chests with cold packs in them. So every parent who enrolled got one of these nice presents. And as an infectious disease physician, it was tough for me to tell them to put the dirty diapers in their freezer, but I overcame that. So if they developed, so we would, any time a child had diarrhea, placebo or vaccine, we would collect the stool and bring it in and test it. And then at the end of the trial, we would test who had rotavirus and who didn't. And that way you could determine the vaccine efficacy. These trials were done in an Annapolis practice and in a Frederick practice. So I had to hire somebody to go collect stools.
What's his name? Desmond Doodoo?
There you go. And here was my doo-doo man. Now, as you can imagine, he didn't really want to make this his full-time career for the rest of his life. Okay. Vaccine development. The vaccine candidates are created in different places. NIH, academia, Center for Vaccine Development, took 20 years, but there was a cholera vaccine that they produced in their lab and finally licensed, and industry. So the candidates can be developed in various places. First, they're animal studies, animal toxicity studies. And then the human volunteer studies. Phase 1 is a small study. Phase 2 is the larger study, and then phase 3. Now, rotavirus, I did phase 1, did phase 2, and then it was expanded to other investigators to get enough kids for phase 3. And that was done around the country. And I was the person who was selected to present the data as it came in to the CDC working group, the Advisory Committee on Immunization Practices working group, and to the FDA. And one of the members of the group one day stopped me and said, hey, we're looking to you for the safety of this vaccine. And I thought, I thought the FDA. But I took it seriously, and I asked the developer, the industry person, to give me a list of every adverse event that had ever been reported in 10,000 kids who had gotten it. And so I got a 32-page printout, font of 8. And I spent an entire weekend poring over that. And I found 5 kids who had bowel obstruction. And took it back to the CDC, and we could not figure out whether it was statistically significant, and regular, normal rotavirus infection isn't associated with a bowel obstruction on intussusception. And so, we really couldn't conclude whether it was causal. We thought it was unlikely, but reported it to the FDA and the CDC. And the vaccine was licensed, but because of my reporting these 5 cases, the FDA did assign a special search code. And they started seeing more cases of bowel obstruction than they thought was usual. And so they halted the vaccinations. And the CDC did an emergency massive study. And they did pick up more cases than would be expected, day 3 to 4 post-vaccination. By then, I was on the CDC Advisory Committee, and my first act was to recommend a withdrawal use of the vaccine I had spent 15 years studying. So I had to kill my baby. It was very traumatic, but needed to be done.
And what's rotavirus?
Oh, sorry. Rotavirus, thank you, is the most common, pre-vaccine, the most common cause of dehydrating diarrhea throughout the world.
I see.
50,000 hospitalizations in the US every year.
It's for adults and kids.
No, kids.
Just kids.
By the time you're a dog, you've had it, you're immune. 500,000 deaths throughout the world. So it's a big deal.
Is it airborne?
No. Yeah.
From kids messing around with feces.
There's a layer of feces
Everywhere.
covering the world.
Yeah.
So, daycare center.
Yeah.
It's gone.
Was there, when you looked at the data, was there anything relative to their genetic, did you see it in the young children in Africa more than you did in developed countries, or?
That really wasn't, it wasn't done that way.
Oh,
Yeah,
no way to discuss.
no way to compare. So don't know the answer to that one. So they have covered that. Okay. While I was in the the throes of all of this, Andrew Wakefield, a British physician, comes out with a Lancet article of 6 kids who had gotten MMR vaccine who had autism. And this just really got everybody very upset, excited, etc. Billions of dollars probably spent studying this. No association was found in any of his studies. It turns out he had made it up. Made it up.
Boy, that makes you doubt Lancet articles, doesn't it?
His co-authors drew their names, Lancet drew the articles. And
Sorry, what did he make up? He made up the fact that there was a correlation?
He made up the patients, he made up the report.
I assume he's not practicing anymore?
He lost his license. Why? I don't know the answer, but he was making a lot of money
Yes.
testifying in malpractice cases.
Oh.
Okay? Yeah. So, so anyway, finally that got straightened out, but that was a tough period. This is, there's always been anti-vaccine. This is from the 1700s or 1800s, the Anti-Vaccine Society. There's a cartoon that I found. I remember when I've seen it, I found it. It was in Punch, the British magazine Punch. And it was an anti-smallpox vaccine article. And it's kind of hard to see, but see, these people supposedly have been vaccinated with smallpox, which is, it is grown in cows. It's cowpox, actually, that's used. So you see cows coming, hordes, cows. So this is nothing new. Now, because there probably is an occasional child who has a serious adverse event, the Vaccine Injury Compensation Act was passed. This was really what stimulated this primarily was actually the false impression that wholesale pertussis vaccines were creating permanent neurologic damage in children, creating autism, for example. It probably never was true, but Vaccine Injury Compensation Act came into play because of that, and they have a list of possible vaccine injuries for which monetary compensation is given. I'm going to show you some images of some of the diseases that were eliminated. Some of them may be a little distressing, but I'm trying to get rid of the awful ones. Diphtheria. One time I went up to rural Canada and I was reading, I would go to these little historical societies, and I was reading death reports, way back from the late 1800s. And there were communities where a lot of the kids died from diphtheria.
And what's diphtheria? What's diphtheria?
Oh, look at those tonsils. It's an infection of the back of the throat. And it can be so severe, that pseudomembrane, that they can choke and die. Oh. Thank you. And anyway, I've been living with these terms.
Did you ever hear it called summer complaint? That was back in the 1800s.
And what was it?
It was diphtheria.
Was it
But
diphtheria?
they called it
Summer complaint?
summer complaint. That was the common farmers.
More than a complaint for some of them. I actually saw some cases of whooping cough, and there's a very characteristic. Which is why it's called whooping cough. Okay. Polio. I can remember being taken to the armory here in Easton and receiving polio vaccine. Remember Roosevelt's March of Dimes? President Roosevelt had polio. And so it had, this is not been that long since this was eliminated. It has been almost eliminated from the world. This poor little fella has measles, how miserable he is. Mumps, remember this, remember having it. Rubella infection, which if it happens in the early part of the pregnancy can cause really terrible damage to the children. Part of my training, Sherman would send us out to school for the blind and the physical, and I guess he got paid for it, but we didn't. And a lot of those kids were there because of congenital rubella that occurred in the 1950s, leaving them blind.
So were they born with it then?
They had it in utero. They were infected in utero, and if it happens early in development, it's quite
It
devastating.
kind of looks like measles.
Yeah, it does, doesn't it? It's nasty. This, there are two bacteria that have a predilection to infect the face. It's in the bloodstream, and then it can lodge in various places around the brain to cause meningitis, in the lungs to cause pneumonia, in the joints to cause a septic arthritis. On the face, this is buccal cellulitis, facial cellulitis, can be caused by pneumococcus, which we now have a vaccine for, by Haemophilus influenza, which we now have a vaccine for. And this, the same bacteria will cause this is called a periorbital cellulitis, infection around the eye. Same bacteria, don't see it much anymore now because of vaccines. Parotitis from ear infection. Epiglottitis, okay, remember the epiglottis? You really open your mouth wide, you can see this tissue come up at your epiglottis, and it's part of what keeps you, when you swallow, it keeps things from going into your lungs. It can become infected, again, by Haemophilus influenza, swell up and block the airway, and that's happened to this child. And that is terrifying when you have a kid in the middle of the night with no ENT or anesthesia back up. I had that happen once. He did okay, but I didn't. Here's fluid in the lung, again, pneumococcus, Haemophilus. Meningitis, his neck, because the surrounding of his brain is inflamed. He's got a stiff neck. And that's one way when you're examining a child, look to see if they had a stiff neck. I think that's chicken pox, I'm not sure, not a good slide. Hepatitis B, cirrhosis. You can see gorged vein because of blockage, because of the large liver, and gynecomastia because it interferes with hormonal production. And we don't see that anymore because of hepatitis B vaccination. Okay, COVID. Here's a diagram of the COVID vaccine. So it's RNA here, RNA, and then the spike protein. And this is the important part to know about. It is, the terminal spike here is what the vaccine is against. And the antibody gloms onto that. And so the virus can't then attach to the human cell. Because this is the attachment protein. And it attaches to specific receptors on the human cell. And it then enters the cell and reproduces in the cell. So if you block the spike proteins with antibodies, that's how immunity occurs. Is that clear? Okay, and here's a picture of COVID. These are COVID particles surrounding cells. And you can see why you feel awful when you get COVID, which I had 2.5 weeks ago.
So the vaccine then makes it so those can't even
Can't
get
attach.
attached.
So why do you get COVID then?
Because the vaccine isn't 100%.
But because you don't have this large mass attacking, you just have fewer, is that what the vaccine does?
Well, optimally, it prevents it altogether,
Right, but it's not.
but it is not 100%. However, it is
Some are sneaky.
very effective at preventing severe disease, hospitalization, and death.
And why is that? Because the intensity, the number?
I don't know the answer.
Is it possible that some of them might attach, but then they lose their virility because of the vaccination, so they can't
Well,
harm as much?
I don't know if it's numbers or, I don't know, you're partially protected. I can't, I don't know the answer to
From
that.
what I understood before about it, the big thing is it changes how your body responds to it. So your body responds less violently. So it mitigates the symptoms by having your body not respond in all the same ways.
The symptoms are due to your own body's response, the cytokines produced by your white blood cells. So you've got me beyond my area of understanding. Is anybody in the audience?
This is just a question about the slide.
Sure.
That very last paragraph, vaccine triggers production of the spike protein, yes, and antibodies specific to the protein?
Yeah. This is, remember I said that COVID is a whole new ballgame when we're talking about antibody, antigen protection, et cetera.
Is that because we're using mRNA for the first time?
Yes. So the mRNA that determines the protein makeup of the coronavirus, of that spike protein. That is, so the mRNA is injected into your body. Your body becomes the manufacturer of the spike protein, okay? So you're cutting out the pharmaceutical company. You are the manufacturer. So the spike protein then is produced by your cells, and antibodies are then produced by you. And
Antibodies to
to the spike protein.
is that what we want?
So so basically what it's telling your body to do is go attack any spike protein that looks like this.
Yes, and the thing that's different is ordinarily in the past, the manufacturer would manufacture the spike protein and inject in you the spike protein, but instead injecting the mRNA and your own body makes the spike protein.
So then, does that answer this question a little bit, that maybe some bodies aren't as efficient in manufacturing it?
That could be. It could be that the COVID mutates a lot, I mean, a lot. And it could be that you're getting some variants that are escaping the antibody. Yes.
Could it just be sheer numbers
I was wondering.
that vaccine gives you the ability to inactivate those spikes? But when you've had a great exposure and a great amount of the COVID enter, your vaccine may just not be able to.
I think that's a likely,
You get a milder case, though.
right, and so it doesn't get to every part of your body in the same, no, that actually makes good sense. Because another thing is, as one ages, then, the incidence of severe disease, hospitalization, and death goes down. And as one ages, you lose T cells. Okay, so your immune response is not as good as it is. So that would make sense.
Do antibodies get used up?
Well, once they attach,
They can do that one time and then that's over with that antibody.
yeah.
So that's why you need a booster.
You need a booster I don't know why the neutralizing antibody, neutralizing antibody wanes. It does after any immunization.
But it doesn't for like some of the childhood ones, like chicken pox and measles and mumps and all that.
Well, typically with the kids, it does, but then you boost it. So they get immunization at 2, 4, 6 months, get at 12 months,
Oh,
and again.
yeah,
at
But not
4,
in
6
adults.
The booster is more to be able to catch some new variants though, right?
For COVID,
Right.
it is, and they're talking about, it's probably time to
Annual
make a new COVID vaccine.
I had COVID after vaccination.
Me too.
My mother-in-law was in an assisted living facility last summer. She's still there. And they had an outbreak there, family COVID. And I had maybe half a day where I didn't feel quite normal. I'm a pretty active person. And then I got tested. And after the first day, other than just being isolated, I had no adverse, felt totally normal. No adverse. I had about 8 or 10 hours of feeling not 100%, maybe 75%, and that went away.
Good.
So it was just amazing. My wife moved upstairs.
Yeah, the worst part is.
My dog left the house.
10 minutes.
I spent a lot of time on my bike.
Yeah, I had it too.
How recent was your vaccine?
It was probably 5, 6, 4, maybe 5 months afterwards. Yeah.
Yeah, there's the FDA, and CDC is talking about probably need for an annual.
Yeah.
Yeah.
That makes sense.
It's just annual, not incremental, not 6 months or.
Well, they're talking about annual, like influenza.
But if you are vaccinated and you have COVID, you can disperse it to those around you who aren't vaccinated, I would imagine.
Yeah, I had it and I was tested positive.
Yeah, theoretically, the virus dies if you were vaccinated, but there must be a percentage of vaccine.
Well, it doesn't develop.
It doesn't develop. but potentially you're able to pass it on.
Well, if you get infected, yeah, because the vaccine wears off, it's not 100%.
I was one of those guys who used to subscribe to MMWR,
Yes.
Morbidity Mortality Weekly Report. I got it every Friday in the mail. It's electronic now. But I read a paper a few weeks ago that kind of substantiated what I read a decade and a half ago. And that at that time, a decade and a half ago, they had identified, I don't know why I remember this number, but 256 varieties of rhinovirus. And this recent paper said, pretty much substantiated that, maybe a little bit more. They subcategorized rhinovirus into 3 different categories. And what this peer-reviewed paper said, well, we've never really had a vaccine for rhinovirus because we're kind of chasing after all of these different variants to smart bug. And then the authors went on to say that COVID's kind of a second or third cousin to smart bug 2, and it's going to be going on and all of these variants too. So we're kind of chasing after something for naught if we've been exposed, we have natural immunity. It was kind of an interesting thing that probably isn't very popular in the way they presented that, and certainly not the way the press presents it. But I got to wonder at some point, are we going to have 256 varieties of COVID, and we're kind of chasing after something that we really can't catch?
I think it's going to be a catch-up game with COVID because it does mutate so rapidly.
And I think what they said too is it becomes more,
Transmissible.
more transmissible, but less
virulent.
virulent.
Yeah. Which
So,
is good.
so if you get COVID, you can still get another variety,
You can,
mutation.
after a while, once it mutates, but I had it 2.5 weeks ago, so I feel like Superwoman. COVID, I'm not gonna give it to you, and I'm not gonna get it from you for a while.
Well, we run into people who say, well, I got it, so I don't have to take any more vaccines. But that's sort of erroneous thinking, right? So-
Yeah, eventually,
Yeah.
I think you're first.
And I was just gonna ask you, where are vaccines not effective? Can we do them against cancer?
Oh, that's a good question. Because aren't they talking about a vaccine for
They
cancer?
are, that's what I was wondering.
For breast cancer, I think. Yeah.
Also, Gloria has a question for you.
Okay.
She said it in the chat.
Oh, let me answer this one. And remind me. What is it?
Is it, let me see, go ahead. Okay.
Oh, okay. Well, I have another slide, but this one, I couldn't resist. One thing we can do is quarantine. But I couldn't resist this cartoon, which is copyright protected, by the way. But hello, I'm just wondering if you put me in the wrong quarantine. Rabies. Okay. Future. Respiratory syncytial virus, still a biggie. I had RSV, coughed for 2 weeks. Then I got COVID, and I think that's why I got COVID, because I think I had really.
Was it more like bronchitis type of
coughed and
symptoms?
coughed and coughed?
Like you thought your guts were going to come out?
Yes.
Yeah.
Yes. Yes, mRNA for cancer vaccines. And then a universal influenza vaccine.
So where are they in that stage with mRNA for cancer treatments? For treatment.
Is that for all types
Not for
of,
prevention, but for treatment.
Treatment population.
all types of cancer?
That's right, I think I, wasn't it for
It's very
prevention?
early, it's probably.
Was that
yeah.
for prevention?
Yeah, so the one we're remembering is, it was a vaccine for preventing breast cancer, I think.
I believe it was breast.
So, something to watch out for.
Yes.
And Gloria had a question.
Yes.
Thanks, Mark.
Can you hear me? So long ago in the 90s, I was hired by Wyeth Letterly Vaccines and Pediatrics, then worked for Wyeth and introduced Prevnar, and then MedImmune, and then I retired. So during the course of my career, I saw many updates and recommendations based on safety data, just as information came out, just as you highlighted with RotaShield. So my question actually has to do with COVID vaccines. COVID vaccines have been linked to a number of serious adverse events, among them myocarditis, especially in young people. And young people have a low risk of serious complications from the COVID vaccine. Instead of taking these concerns seriously, it seems there's a doubling down to recommend these vaccines to young people. And I'm just wondering what's going on.
Ooh, well, I'm no longer on those committees. I think it's probably, it's risk benefit. And I'm assuming that they're taking this, these couple of cases of myocarditis seriously and weighing the risk benefit. And I'm no longer in those discussions, so I can't, I really can't comment.
So what happens when they see a risk come up, then they're looking at the percentage, the potential for it to become a bigger risk? Is that, when you say weighing that?
Almost anything in medicine, every medication you take, every surgery you undergo, there is a risk benefit that you need to factor. So let's say, COVID itself can cause myocarditis.
So do they?
So if it's the vaccine is causing 1 in a million cases, but it's preventing, 10 in a million cases, and the risk benefit goes towards the vaccine.
So does the FDA eventually come out and say that there might be a risk in X percent of kids under age, blah, blah, blah?
Yeah.
Is it a percent that they give, or?
Well, it's not, not sure they even have enough data on the myocarditis to say it's a percent, but we have somebody who used to work at the FDA.
Yeah, Pam, answer that question. Oops, you're on mute still, sir.
Well, we really need probably another session on clinical trials to begin with. I think Peggy would probably agree, because when trials are sized for power to detect things, there is an agreement before the trials are even run as to what that risk-benefit ratio is. Everyone agrees on what is suitable or acceptable at each stage of any trial, and certainly for the confirmatory trials that occur just before licensure. For example, I came in right about the time that rotavirus had to be pulled, let's say, and the information from NIH, but I was on the license for varicella and Prevnar, one that Glory just mentioned. And so there's something called vaccine efficacy, and among other things with safety, all of these things are part of the, if you will, contract that is established before any clinical trials go forward. And then as, we'll call them signals, they're not really, because that's like metadata, but when various signals come up, and Susan Ellenberg at the time developed the VAERS system, VAERS, that has to do with the vaccine adverse event reporting. What you have to remember is that you get a signal from anywhere, physicians, patients, anyone that knows the patient, and what you don't have is a denominator. So you have this noise, and it has to be determined as to whether it's attributable. So I mean, I'll kind of stop there. There's not a specific answer. If there's an issue that comes up, it goes immediately to advisory. And there's going to be one tomorrow because many scientists and people on the vaccine advisory committee do not feel that there is science base to the annual suggestion for COVID. But of course, this will develop as well.
Thank you.
I'd like to get back to what Gloria suggested too. I think sometimes we just don't know what we don't know yet. And this has not been around a while. I remember decades ago when I was a young buck, before we deployed, I remember they were giving us oral prophylaxis for malaria. And then they jabbed us with cholera injections. And I was lucky, I didn't get sick, but there were a lot of the guys that I served with that were getting sick because of that sort of thing. So I think it takes time to kind of figure things out. I had a conversation last month with a flight surgeon who's in the National Guard. And we talked a little bit about a paper that we both read and the incidence in the military of COVID adverse reactions. Let me restate that. Reactions to the mRNA was about 1 in 15,000. And I remember what this physician said. He says, well, if you're the 1 in the 15,000, it's 100%. So what we're seeing in the military are strokes, myocardial infarction, myocarditis. I happen to know of a young fellow that I was mentoring a couple of years ago. He got his second mRNA inoculation. The next thing you know, they were flying him down to DC to see a cardiac, just turned 18, pediatric cardiologist. So it's happening. I think it gets back to the clinical trials. It's going to take some time. And the biggest clinical trial really is general population, right?
That's right.
So I guess we just don't know what we don't know yet.
Right. Well, I think the rotavirus trial is a good example. There were 10,000 vaccinees in the rotavirus trial. We now know that the valve obstruction, that first rotavirus vaccine, happened in 1 out of 10,000 kids. So that was not enough. But that wasn't known going in. So you couldn't say, okay, well, we've got to power this trial there was nothing to put in the formula.
So you couldn't, once you learned that it was fairly inconsequential, you couldn't go back out to market with that rotavirus?
Well, 1 out of 10,000, if you're vaccinating 4 million children, is too many. And what happened was other manufacturers came up with other rotavirus vaccines that didn't have the complication.
Oh.
So, problem solved.
Are you going to describe how mRNA vaccines are made?
Oh.
Question? How they're made?
How they're made?
How do you make them?
How do you make mRNA
Yeah.
vaccines?
Yeah.
Well, each of the viruses is attenuated, is weakened, and then they are mixed together. And, but beyond that, I will turn to Pam.
Maybe Pam, maybe you could explain what mRNA is.
Measles, mumps, rubella.
Okay,
Oh, I thought it stood for messenger.
yeah,
No,
Messenger,
mRNA.
messenger RNA?
Oh, I'm
Yeah.
sorry. I thought you said, I misunderstood you.
yeah.
Say your question again.
How mRNA vaccines are made? Manufactured, is that a better word?
Yeah.
Um,
Created.
Yeah, well, they. I don't know. Pam, do you know how
Short
they
answer,
actually
please.
make the mRNA vaccine?
No, I couldn't, I mean, I could come up with my version of a description. That wouldn't be probably either suitable or appropriate. I'm not an immunologist. It might be of interest for the group to hear the difference between, in general, adaptive vaccines, perhaps like your mRNA, versus the adenovirus ones that are also very highly effective against COVID, like Novavax, and I'm trying to think of the other one, because they're so completely different as to how they immunize or sensitize, I should say, the immune system, and presumably make it adaptive, actually, in terms of different variants or exposures. And people who, the myocarditis, and of course, Peggy, you can speak certainly medically to this, but as I understand it, this young person myocarditis issue that popped up in the UK initially as a big flag has sort of been damped in that, first of all, it's highly treatable. Second of all, it occurs very frequently with any viral infection among that group of people or young people. But third, that if you're infected with COVID, the incidence is incredibly higher. So I would guess, again, that there's a benefit risk that the different committees, ACIP or others, will take up. But no, I can't speak specifically to the mRNA. I've studied it, but I'm not an expert.
I think she's more of an expert than the rest of us. Well, that kind of gets to the issue of what is mRNA, and that's a pretty new field, right? It's kind of to be able to
It's
make.
a brand new field as a vaccine.
Right.
And what it is, okay, you have DNA in the nucleus. Remember I had that pretty cell, so the DNA is in the nucleus. RNA is like a template made from the DNA. And that, as it goes to the endoplasmic, that's made in the endoplasmic reticulum. And then that messenger RNA goes to the Golgi body of the cell, where it is enveloped and presented to the outside.
So somehow scientists have figured out how to messenger.
Well, it may be able to actually create it if they know the nucleotide sequence.
Well, DNA, the sequence, determines the structure of a protein. The M in the mRNA stands for messenger mRNA. It leaves the nucleus, goes out where the proteins are produced. So I think that's why they're calling it mRNA, is it's taking the code from the nucleus out into the body of the cell to make the protein that's going to protect you.
That's a nice explanation.
I'm going to take a stab at this. There was a process developed by Hoffman LaRoche's Genentech, South San Francisco, and I suspect that this is produced by bugs, bacteria, and then it's extracted by liquid chromatography. That's just a guess on my part, but I suspect that's why they can make so much of it, why it's a lot of those kinds of liquid chromatography substances are so expensive. So just a guess, but I think that might be, I'll look into that. How's that?
Well, yeah, so because that gets into the question of how is it produced in the big scheme of things to be able to get that vaccine out to so many people. And wasn't that part of the issue at the beginning? They didn't know how they were going to do it.
I wanted to go back to Lori's question about this. I think her statement is exactly true, that there have been a lot of cases of this. I think a lot of it has to do with the emergency use authorization that they gave to this. So they did not complete these 3 phases of the safety study, and they do not have all of those results. It was sort of put in place, like when you go to get the shot, do they tell you the contraindications? Do you know what the side effects? No, you're not getting any of that information. You're just getting a kernel. I have been watching, there's a YouTube channel called John Campbell out of the northern part of UK, and he has been following the COVID situation in UK, US, and around the world for several years now. And he has guests on his show, maybe every 3rd or 4th time. And there's a doctor from Australia, Dr. John Clancy, who's had 40 years in immunology, who knows all about infections and about the vaccines. And he says, we've been making vaccines for a long time. And basically the essence of, we inject into you a certain amount, a controlled amount, and that has the effect. We do studies to find out the right amount. The problem with mRNA vaccines, when it goes into the body, I think initially it was thought it was going to stay in that muscle tissue. It doesn't. It goes all over the place. They found people that have died, and it's surrounding their heart, so they're finding evidence of, and he's saying, the mRNA vaccines cannot control the amount of antibodies that are there, because it just produces in all sorts of places. It says, and it brings up a question. Wait a minute, hasn't this been 2 years? Why don't we have a regular vaccine like the flu vaccine? Why haven't we done that? I understand China's working on it. Some other countries are working on it. But if it's a controlled problem, that someone gets huge spikes in that, one of the most dangerous things, when they inject you, if it happens to get in the vein and not in the muscle, it's very bad, because it spreads all over the body. It's in your circulating system, which is bad.
So is there a point in time when it loses that experimental tag, and they're all that data becomes studied, and they can, instead of being provisional, they can give it that final status?
Again, I'm not on the committee,
Well, I mean, just in
But-
general with the way these are done.
but in fact, the largest trial of any vaccine has already been, has already been completed. Millions of people have gotten these vaccines. And we do have, as Pam said, the vaccine adverse reaction. Anybody can report any reaction, and that gets monitored for signals. And, there have not been disturbing signals.
We get lots of anecdotal information,
Absolutely,
and that's
social media.
and that's so different from statistical data.
Absolutely.
So
The VAERS system has shown, the numbers on the VAERS system are something like, for the COVID vaccine, hundreds of times more than all the previous vaccines ever produced. So, I mean, there is a huge signal there
Oh, what?
for the COVID vaccine.
Oh, the signal for.
but what the hundreds of the adverse reactions?
Adverse reactions,
But you have to remember, those adverse reactions can come from any source. And
yes.
there's no way to know if it's being over-reported by a family member or a friend or a dog.
And, I mean, all of us got sore arms.
Right,
That's an
That's
adverse
that's
reaction.
nothing to me.
The serious.
That's nothing.
but those show up in
Yeah.
those reports.
Yeah, so
When COVID first began, though, the warnings were that people with heart conditions were more seriously affected and respiratory issues. I'm a big believer in the odds. And so I think if I had a heart condition, I would get the COVID vaccine.
Yeah.
If I had asthma, if I had those preconditions that seemed to have a higher rate of hospitalization and death, when that vaccine came out, I want to get it.
So Pam had her hand up.
Now, I can't remember what we were talking about before. I think it was the various risks and Campbell. And I'm a big fan of Campbell, but I always balance his against Roger Schultz and Eric Topol that have sort of parallel running information on all of this. And Campbell's issue early on 2 years ago was the retraction before injecting to make sure it was not in a vein. And that is the very terrible outcome that people will have if you have the injection directly into your venous system. But in any case, there are 7 databases, as I understand it, that are being monitored in parallel, each of them that collect the data in very different ways. And this is not FDA. This is the, in addition to the VIIRS system, if you listen to any of Campbell's reports, you'll hear the other 6. And they're typified in very different ways. And some of them do have denominators, who was exposed versus the frequencies. And you get very different visions or versions of what might be going on. So that's all I know at this point. I watch all of them. Thanks.
We call her Pam the nerd. So we still have 10 minutes. So any more questions or discussions?
I think this still gets back to, we just don't know what we don't know. I read a piece this morning while most people were enjoying REM sleep, and it came out of Japan, and they said for the first time in decades, their population actually decreased. Same thing in China, was a report that came out last week.
Yeah, but nobody
that the
believes
population in
China's
China.
stats.
And so there's some conspiracy theorists, if you want to say that are attributing this loss of population to an adverse reaction to mRNA. I might suggest that it's just fewer people are doing the Memphis Mambo. I don't know.
well, that and in
The
the
Memphis
US,
Mambo.
and in the US, it's fentanyl.
Yeah, sorry.
In the US, it's fentanyl.
Oh, gosh, yeah.
Leading cause of death.
Yeah.
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 Fentanyl.
So one of the things that strikes me in your discussion and listening to some of the questions is that we have physicians who are thought leaders with their patients, right? But not all physicians are on board yet. Or they may have some questions or they have or concerns that they're seeing that's relative to their specialties. And so, you spend a lot of time educating people on your vaccine. And maybe some of the education still hasn't gotten all the way out there to the physicians, or maybe the physicians are going in, that some of them are going, specialists are going in different directions. I don't know. So I know I've heard most cardiologists, 2 of them now, have told him not to take any more of the vaccine. So that kind of goes against the thinking that if heart problems are more, have a greater risk, then why wouldn't you be taking it? So I think that would be, that's kind of curious,
Yeah.
so,
Just very curious.
yeah. So,
Well, all physicians are not created equal. What can I say?
This question is, what do you call the doctor who graduated, what do you call the person who graduated last in medical school? Doctor.
yes, there's still a doctor. And we are in a rural area, that's maybe some of the best doctors. I don't know. Maybe, I don't know.
Well, I can tell you this. Not a lot of people flunk out of medical school. It's hard to get in.
Yeah.
Yeah.
I think we do a little bit of genomic market research. So we work with a lot of people around the globe with genetic sequencing or next-gen sequencing. And so I think it would be interesting to see if at some point there are any genomic changes caused by mRNA. We know that, for example, with a typical next-gen sequencing, we produce about 52 pages of data in 4.5. And we only know what the first page, first 3/4 of that first page actually means. There's so much stuff there that we haven't been able to figure out yet. So it'd be interesting to see as that technology advances, if we're going to learn anything through that, between artificial intelligence will actually make some correlations between clinical results and all these figures that are on those 52 pages of data. So.
Peggy, there's some areas of disease that use these smarter vaccines, where what have I read about leukemia, I think is one of the areas that has been very successful for the new format of vaccines.
Are you talking about the mRNA vaccines?
Isn't that right? Isn't there some real examples of success using the new technology or developmental methods?
Well, we should be thankful that there's so many scientists out there studying these things because that's our future. And I hope that we have a future that's cancer-free at some point. So.
And fossil fuel, you're free.
That's another issue. Yeah. Well, thank you so much, Peggy, for tackling this subject.